Hi, hello, my dear beautiful students. Welcome to your favorite channel. Before going to the demo session, let me introduce about myself. So, this is Vivek. I have 14 plus years teaching experience in IIT JEE as well as in NEET exam beta. Okay, right. So, in the past, I used to work as a HOD in Bansal classes. Next, I have shifted in PW Telugu vernacular. So almost I have worked there for 1 year. Next, you can watch my videos from PW English also. So I have taken some classes in PW English channel also, right? So after leaving from PW, so I have started running my own organization with the name Physics in Telugu. Okay. Yes, so this is my complete teaching experience I have put in front of you. So without wasting any time, let us start our demo session. So today I am going to take the demo on work, energy and power chapter beta. Okay, so actually this chapter comes in class 11th. Okay, yes. Before going to start the topic, so I want to tell you what is the score, how many questions you will get from this chapter in JEE as well as in NEET exam. Okay, those who are preparing for JEE, definitely you will get one question from this chapter, and those who are preparing for NEET exam, so you may get one or two questions from this chapter beta. Okay, yes. So to understand the physics in a simple and easy way, I am going to use very simple language. Okay, right. So very simple language I will use, and very neatly and detailedly I will clear you the concept beta. Okay, so even you are from Marathi medium, Kannada medium, Telugu medium. Okay, yes. So whatever you are in a different mediums, but I will explain you in a simple and detailed manner. Okay, yes, beta. Now, so here work, energy and power, the chapter name we have. The first topic in this chapter we have about the work. Okay, yes. So what is work? Yes, beta. Yes. So everyone know the formula for the work, right? So most of the students, if I ask you the question, what is work? They used to tell that, sir, if we apply some force on an object, it displays, it moves some distant. This is called as a work. So like this they used to tell. Okay. Yes. So yes, you are correct. Almost correct only. Now I will tell you what exactly the work is. Take a block, okay, having a mass m, put it on the surface of the earth. Clear? Yes. So there is no friction in between the block and the floor. Clear? So there is no friction you have here. Okay. Now apply some force on this block. Okay. You are applying the force, right? Yes, so you are applying the force with your finger on this one, right? What happens, beta? Everyone know, sir. If we apply some force on the object, it start move from one place to another place. Am I right? Yes, correct. So you are applying the force in this direction. Of course, the block will move in this direction, right? In the same direction in which you have applied the force. Correct. Now, so it has moved from here to here, right? And so I'm indicating the distance travel by the block from this position to this position is S. Clear? Okay. Now, so if anyone asks you what is the work done on this block, you have to tell that the work done. So this is a work done by you, right? Because you are applying the force with your finger on the block, right? So if you apply some force, what is happening? It is moving from one place to another place, right? So this work is called as a external work. Externally, you are doing some work on the block. Yes, correct. Yes, so that's why I have mentioned here the external work done by you is equal to the force you have applied on the block, okay, and how far it has been traveled. Okay, it has been traveled a distance s, and this is called as work done. Okay, right. Now, sir, if we apply the force, does work happens? It means work will be done. See here, beta, whenever you are applying the force on the object, okay, so I'm taking this as a wall. Okay, I'm taking this one as a wall. You are applying the force on this wall. Okay, now even you are applying the force on the wall, does the wall will move from one place to another place? No, it will never move. Why? See here, because the friction between the wall and the ground is very high, correct? Yes. Here, the force is present. Here, the force is present. Even you are applying the force, but there is no displacement. Yes, correct. So then, what is the work done by you? So here, what is how much you have work done? It is a completely zero because there is no displacement we have. Okay, yes, so that's why the work done will get here zero beta. Okay, right. So main thing what you have to remember is, if you apply the external force, the body may or may not move. Okay, if it moves, if the body moves, then the external work has said to be done. Okay, here the object is moving from one place to another place. Of course, the work is said to be done here, but in this case, even you are applying the force, but the displacement is zero. Okay, so finally work done, what you get? Zero only, because the work done formula is you have to apply the force. Yes, you are applying some force, but it is not displaced, it is not moved, right? So finally the work done is what? Zero you got here. Okay, right, beta. Now here most of the students will by heart the formula of work. Okay, so here the work formula they used to by heart is Fs cos theta, if theta is the angle between force and the displacement. Okay, without knowing this angle theta, okay, blindly they will by heart this formula. So by hearting the formula, where you are going to do the mistake, I will show you clearly, beta. Okay, now see here. Okay, see here, this is a block. You are applying the force in this direction. Okay, you are applying the force, okay, in this direction, okay, by making an angle theta. Clear? Now when you are applying some force in this direction by making an angle theta, what happens? Everyone know that, sir, this will be moving in a forward direction. Yes, am I right? So finally it reaches here. So it travels some distance, correct? Yes or no? Correct. So it is traveling some distance from here to here, correct? Now, what is the work done in this case you have to take? Sir, here the force is in this direction, but the block is moving in this direction. As here you have an angle between the force and displacement. Am I right? Okay, correct. Now, what is the work done formula you will get here? Sir, again we get force into displacement. No, you won't get this one. Because here the work, how you have to write the formula for the work is, you have to take the force along the direction of displacement. Okay, here the force and displacement both are not in a straight line. Yes or no? Yes, sir. The force is in this direction and the displacement is in this direction. Both have some angle theta, but both not in a straight line. Okay. So note this point. Note this point. Whenever you find the angle between the external force and the displacement, you have to take the force which is along the direction of displacement. Okay, very important. The force is always taken along the direction of displacement. Okay, na? Right, beta. Yes. So see here. Ah, sir, how to take that value? I will help you how to take that one. Okay. See here, wherever the theta is present, wherever the theta is present, attached to that one. So in the same direction, you will get f cos theta beta. Okay. This is a trick you have to remember. Okay. This trick not even it will apply here. It will apply in complete physics. Okay. The first key point you have to know is you have to resolve the components. Okay. Component resolution we call it. So this one you have learned in your vectors, right? Okay. If you don't know the topic, I will help you here. Okay. See here, beta. Wherever theta is present, okay, there you will get cos theta, and exactly 90 degrees to this one, you will get sin theta. Okay, whatever the force here you have, put down that first. Next, write down the cos theta. Okay, here you will get as a sin theta. Is it clear, sir? Is it always necessary that 100% will get cos theta along x-axis? No, it is not necessary that 100% always we get cos theta along x direction. Okay. See here, this cos theta depends upon where you are taking the angle. Okay. Which one you are taking? If you are taking the angle here, theta, then you will get cos theta here. Okay. So I will tell you one trick to understand this concept very easy. Okay, so already you have learned this one in your vectors chapter. Okay, this is a banana. Okay, you want to eat the banana. What you will do? You will peel off this one, right? Yes or no? Yes, the component resolution exactly work like a banana only. Okay, so you will be peeling off one like this, and next will be like this. These peels should be always perpendicular to each other. Next, see here, the key point you have to remember is when you are peeling the banana, okay, this peel should be always perpendicular to each other, beta. Okay, next you can eat the banana easily. Correct. Now see here, this is a vector. So this is the angle theta. Okay, so where we get cos theta and where we get sin theta. Okay, see here, I will explain. Here the A is present in this direction. Correct. Yes, so here assume this one as a banana. So for the banana, what you will do? So you will peel that one, right? So you are peeling in this direction one, and next one will be in this direction. Correct? Yes. So wherever the theta is present, there you will get cos theta beta. Okay. So whatever present is here, okay, whatever it may be, write down that one here first. Next, write down the cos theta. Okay, exactly 90 degrees. What you get is sin theta. Is it clear, beta? Now, tell me the answer for this one. If the angle is here, okay, let this be the B. You have to resolve the components. Okay, now how you will do this one? So assume this one as a banana. Now you'll have to peel out, right? So one will be in this direction and one will be in this direction, right? wherever theta is present, there you will get cos theta, correct? So here you have b na, here you will get b cos theta, and here, so another peeling out, right? So here you will get sin theta beta, that's it. Okay, now if this is the p, okay, this is a p I am taking, and the angle is theta is here. Okay, now you have to find out the component resolution of the p. Okay, now how you will do this one? Wherever see here, this is a banana, you are peeling out like this, right? Correct, you are peeling out like this and like this, correct? So here you will get wherever theta is present, there you will get cos theta, and exactly 90 degrees you will get sin theta. Is it clear? Okay. Yes, see here. So you got a perfect idea regarding the component resolutions, right? Okay. See here, if this is a t and if this is theta. Okay. Now write down the component resolution for this one. Okay, this is a banana, you have to peel out like this, and one is a like this, correct? Yes. See here, so here what you get? Okay, so for here, wherever theta is present, there you will get cos theta, and here you will get sin theta. Okay, so now you got a perfect idea regarding the component resolution. One more point, without the basic knowledge of component resolution, you are unable to solve a single numerical in physics. Okay, so you should know the idea about this one. Next, easily the numericals which are present on work topic, you can solve that one. Okay, yes, Nana. Now see here, so what is the work done? So just now we have solved this one. Okay, so this is the external work done. Okay, and this is the displacement you are getting. Yes, and this is the angle theta. Okay, the work. Okay, to calculate the work, already I said you the note point. I have given you the note now. What is the note I have given? The work. Okay, external force you are applying, it means external work you will get here, right? Wherever theta is present, there you will get what? Cos theta. Yes, so here you get cos theta. This is the banana, right? So one is you are peeling out like this, and one is in a upward direction, right? Okay, but so the main thing is you have to remember that one is these two peels should be perpendicular to each other. Okay, this is the f sin theta beta. Okay, to calculate the work done, you have to take the force and the displacement should be in same direction. Okay, here f cos theta and the displacement both are in a same direction. Okay, you have to take this one only. Okay, f cos theta into displacement. Clear? Most of the students will by heart this formula. Okay, fs. So finally what you get? Fs cos theta you will get. Is it clear? Next, the next point is here. In exam, if he give, okay, if he give like this, so here you are applying the 10 newtons of force. Okay, by making an angle 60 degrees. Okay, so this block has been moved to a distance of 10 meters in a forward direction. Okay, this block has been moved to a distance of 10 meters. Okay, so you have to calculate the work done here. Okay, now see here, so most of the students, 90% of the students will by heart this formula. Okay, yeah, so directly they will what they will do, just they will by heart the formula. What is that one? Fs cos theta. They'll put the values here. F value is 4 he given, and the displacement he given 10. Okay, the force he given 10 and the displacement he given 10. Correct? And the theta value he given 60 degrees. They will put the value cos 60 degree. So this is 100. Cos 60 is what? It is 1 by 2. So finally, in option, you will have this 50 joules. But this is a wrong answer. Okay. The thing is, you have to learn the concept here. Okay. You should not by heart the formulas. Okay. I am here you to teach you the concept only, not to by heart the formulas, beta. Okay. See here, I have so just now what I have said you the point in work, the force and the displacement both should be in a same direction, right? Force and displacement should be same direction. So what he given here? Okay, the angle given here. So just now I have explained you the component resolution also. So in that one, take this one as a banana and just peel out like this. Okay, and so here what you get, beta? It is a 10 cos 60 degrees you'll get. Okay, wherever theta is present, there you'll get cos theta, and here you'll get sin theta. Am I right? Yes or no? Yes. So now observe carefully. The force and the displacement should be in the same direction. Na? Yes. So the force in this direction, the force is 10 sine 60 degree. That is 10 into sine 60 is what? Root 3 by 2. 2 5 are. So finally the force, what you got? 5 root 3 you got. Correct? Along the x-axis. Yes or no? What is the force you got along the x-axis? That is 5 root 3 you got. Is it clear? Right. Next. So how far it has been traveled? When you apply this force, it has been traveled 10 meters of displacement. Correct? The force is in this direction. Correct? The force is what you got? 5 root 3, and the displacement is 10 meters. Both are in same direction. Correct? Whenever these two are in a same direction, so here you have to calculate the work now. Okay, so what you get, beta? What is the work you get? Force into displacement. Now what is the horizontal force you have? 5 root 3. Okay, 5 root 3, and what is the displacement it traveled in x-axis? 10 meters. Correct? So finally what you got, beta? 50 root 3 joules is the final work done. Okay, 50 root 3. See here, in option he will give you the 50, and in option, the another option, he will give you the 50 root 3. The person who have learned the concept can put the correct option, beta. I hope you this has been clear for you, right? Now one more thing. Here the work done is a scalar quantity. Work is a scalar quantity. Work is a scalar quantity. Okay, the work formula you have to write like this. Here, F bar dot S bar. Okay, here I will tell you the one more trick for you. Whatever the, so this trick will be applicable from kg to phd. Okay, in scalar quantity, if they are scalar product. Okay, work is a scalar quantity, and this is a scalar product you'll get. Okay, every scalar product or dot product, this is what? Dot. Okay, this is what? Dot product. Every dot product should be parallel to each other. So 100% you have to remember this one. What is that one? Every dot product should be in straight line. Okay, every dot product should be in straight line. See here, I will ask you one question here. Here this is a and this is a B, and this is the angle theta. Write down the dot product here. Okay, write down the dot product. So the resultant, what you will get, beta? The resultant, what you get? Already I said you the trick. What is that? The dot product should be always in a straight line. Yes. Now tell me, A and B both are in a straight line? No, they made some angle between them, right? Okay, now tell me which are in a straight line. Sir, wherever the theta we have, there we get p cos theta, right? Exactly 90 degrees what we get? P sine theta we get. Am I right? Now tell me which are in straight line. A is in a straight line and B cos theta is in a straight line. As A is in this direction and B cos theta is also in the same direction, right? Now, so the resultant will become what? A, B cos theta. Is it clear? So, write down this one in vector representation. R bar is equal to A bar dot B bar. Okay. So final answer you will get what? Magnitude of R bar is equal to what? A B cos theta. Okay. Remember this one. In case by mistake, if they are perpendicular to each other, okay, which are perpendicular? B sine theta and A, na? Am I right? A is in this direction and B sine theta is in this direction. Remember this one. Okay, if dot products are perpendicular to each other, if dot products are perpendicular to each other, then the resultant always you will get 0. Remember this one, beta. Okay, easiest way to solve the numericals. Okay, is this clear? Do you have any doubts here? No, na? Every dot product should be straight line, but they should not perpendicular to each other. Okay, every cross product should be perpendicular to each other. Okay, this one, all the things you have learned in vectors chapter, right? Every cross product should be always perpendicular to each other. Okay, by mistake, if they are in a straight line, then cross product will become 0. Okay, the cross product will become 0, beta. Is this clear to everyone? Okay, the work done is a dot product. A dot product is nothing but every term should be in a straight line only. Product, it is a dot product. Product is nothing but what? Multiplication. Okay, the force we have and the displacement we have. The force is multiplied with the displacement. We get the work done. Is it clear? Okay, so yes, so till now almost the half an hour video has been finished. In order to complete this one, it take 30 more minutes for me. Okay, that's why I'm stopping the class here itself. To complete the work concept, a small formula, that is work equal to force into displacement. I can explain this one for 1 hour. Okay, I can explain this one for 1 hour. So 50% has been finished and rest of the 50% I'll let us continue in the next class then. Okay, yes, so thank you so much. Bye beta.